Imagine holding something in your hand, so small you can't even see it, yet it contains enough power to light up an entire city. That's not science fiction, that's nuclear energy. It's one of the most powerful forces in the universe, hidden deep inside every single atom around you. In the air you're breathing, the water you drink, even the chair you're sitting on right now. But what exactly is it? And how do we manage to tap into something so incredibly strong without, blowing everything to bits? To understand nuclear energy, we have to start with the atom, the tiny building block of everything. Picture it like a miniature solar system. At the center is the nucleus, acting like the sun, and orbiting it are the electrons, like planets. Now, inside that nucleus are protons and neutrons, all packed together by something scientists call the strong nuclear force. And trust me, they're not exaggerating. This force is what stops the nucleus from flying apart, even though all the positively charged protons inside are desperately trying to push each other away. It's like trying to make a group of hyperactive toddlers hold hands. Something incredibly powerful is needed to keep them together. But what happens when that balance is disturbed? Well, the result is spectacular. In nuclear reactions, we either split heavy atoms apart, that's called fission, or we fuse light atoms together, which is fusion. Both processes unleash a staggering amount of energy. Why? Because a tiny bit of the atom's mass gets converted directly into energy, following Einstein's famous equation, E equals mc2. That c stands for the speed of light, and since light moves ridiculously fast, even a tiny amount of mass explodes into a mind-blowing amount of energy. To give you an idea, splitting just 1 gram of uranium is equivalent to burning 3 tons of coal. That's some serious power from something you could fit on your fingertip. In modern nuclear power plants, we use fission. We bombard uranium atoms with neutrons, causing them to split. This split releases more neutrons, which then hit other atoms, creating a self-sustaining chain reaction. To keep this from getting out of control, engineers use control rods and coolants in a delicate dance between nature, raw power, and human precision. All this generates immense heat, which we use to boil water, spin turbines, and create electricity. It's the same basic principle as any other power plant, just with a much more potent heat source. Of course, nuclear energy has a dark side. The same process that lights up our homes can, if mishandled, lead to disasters like Chernobyl or Fukushima. And even when everything goes perfectly, we're left with radioactive waste, materials that stay dangerous for thousands of years. It's like hosting a party where some of the guests refuse to leave, ever. Scientists are working hard on solutions, from storing waste deep underground to developing new reactors that produce less of it. Then there's the Holy Grail, nuclear fusion. This is the process that powers our sun. With fusion, we combine light atoms, like hydrogen, to form heavier ones. This releases enormous energy without the long-lived radioactive waste of fission. The catch? To get 2 hydrogen atoms to fuse, you need temperatures and pressures similar to the core of a star. We're talking millions of degrees. It's like trying to make 2 cats hug. It's almost impossible. But we're getting closer. Recently, scientists achieved a major breakthrough, creating a fusion reaction that produced more energy than was put in to start it. For a split second, we recreated the power of the sun on Earth. Despite the controversy, nuclear power is one of our cleanest large-scale energy sources. Unlike coal or gas, it produces 0 carbon dioxide. In a world racing to stop climate change, that's a massive advantage. Countries like France, which gets most of its electricity from nuclear, have some of the lowest carbon footprints in the industrialized world. The word nuclear might sound scary, but this energy has saved millions of lives by reducing air pollution and powering our modern world. It's not good or evil, it's a powerful tool that demands our respect and responsibility. So next time you flip a light switch, remember the incredible journey that power took. Deep inside a reactor, a tiny invisible storm is raging, atoms splitting, energy bursting forth, all so that a single bulb in your room can glow. The universe hides its greatest power in the smallest of places, and it's up to us to learn how to wield it wisely. Thanks for watching. If you found this as fascinating as I do, make sure to hit that like button and subscribe for more deep dives into the science that shapes our world. See you in the next one.